So for question 2, we have a complex number z1 shown on the diagram. So here we have it. We want the value of a and the value of b. Well, the value of a is on the x-axis and the value of b is on the y-axis. So this value must be 3 and this value must be -1. So part 2, we want to plot this complex number on this diagram. So again, this value is on the x-axis, this value is on the y-axis. So this is -1. This value is 2. So this here must be z2. And for part 3, we have z3 is equal to z1 divided by z2. Write z3 in the form x plus yi. Okay, so we know z1 is equal to 3 minus I. We can see it here. z2 is equal to -1 plus 2i. So z3 then is equal to these numbers, z1 divided by z2. What we can do is multiply above and below by the conjugate of the denominator, and the conjugate just means you change the sign in front of the imaginary component. So we're going to multiply by -1 minus 2i and -1 minus 2i. That is equal to -3 plus I minus 6i plus 2i squared. And here we have 1 minus 2i minus 2i times -1 is plus 2i. Minus 2 times plus 2 is minus 4i squared. And that is equal to, well, up here we have -3. Over here we have 2 times I squared, but I squared is -1. So that's going to give us -5. We have plus I minus 6i is -5i. Divide that by, these two numbers will cancel. I squared is -1, so this is going to be +4, and 1 is 5. And that is equal to -1 minus I. So for part B, we wish to solve this equation for z. The first thing we are going to do is solve the right hand side. We'll get -4 plus 2i plus 4i minus 2 times I squared, and that is equal to -4 plus 2i plus 4i minus 2 times I squared is -1, so that will be plus 2, and that is equal to -2 plus 6i. Okay, so we have 2z minus 6 fours is 24 plus 36i is equal to this. So we have 2z is equal to -2 plus 6i plus 24 minus 36i. That is equal to -2 plus 24 is 22 plus 6 minus 36 is -30i. So z then will be equal to 22 minus 30i divided by 2, and that is equal to 11 minus 15i. So that's question 2 complete.